We want to finish up today by looking at some homework problems. So one of the first questions has to do with whether a matrix is in an echelon form or a reduced echelon form or neither. So in this case, we need to identify where the pivots are. There's a pivot in the first row, first column, second row, second column, and a pivot in the third row, fourth column. So we see that each pivot column has a 1 in the pivot position and zeros elsewhere. Therefore, this matrix is in reduced row echelon form. If this was the augmented matrix of a linear system, then we would say that the linear system, the corresponding linear system, is inconsistent. This is not the augmented matrix of a linear system. That wasn't part of the problem. We just want to determine echelon form, reduced echelon form, or no echelon form. So that wasn't part of the problem, but it's good to observe these kinds of things. Note, if this is the augmented matrix, well, let's just write it this way. This is the augmented matrix of an inconsistent system. That wasn't relevant to this problem. That's not relevant to the reduced echelon form or not. That's just what we would conclude based on the reduced echelon form. So if I said, is this in reduced echelon form? The answer is yes. If I ask the question, is this the reduced echelon form of a consistent system? The answer is no. So this is an important note, but not relevant to whether it's reduced or not reduced. So I can absolutely see why this is confusing, because we want to think of it as kind of a yes or no question, but it's a different yes or no question. So good question. I like that one.
Sorry, can we go through the part D as well? Because this one is so confusing for me.
Yeah, let's look at the matrix in part D. Let's see, 121, part D. So in part D, we've got 1, 0, 0, 0. Then we've got 1, 2, 0, 0. We've got a column of zeros. Then we got a 1, 2, 3, 0. Then we got a 1, 2, 3, 4. So we need to identify where the pivots are. There's a pivot in the first row, first column. We go over to the second, down to the second column, down to the second row, over to the second column. Here's where we would have a pivot. We're not going to get a pivot in the third column, so we move to the fourth column. And in the third row, we could put a pivot there. And in the fourth row, in the fifth column, we could put a pivot there. So this is not reduced row echelon form, but there's zeros beneath all the pivot positions. So it's in a row echelon form. So this is in row echelon form. But not reduced.
So the reason that it breaks the law is that the number for each pivot point is not 1.
There's two reasons. First of all, the pivots are not just ones, and also there's not zeros elsewhere. It's in echelon form because there are zeros below the pivots. So zeros below the pivots mean that we have an echelon form. But it's not ones, so it's not reduced, and it's not zeros elsewhere, so it's not reduced. Oops. Not ones, so not reduced. And in addition, it's non-zeros elsewhere in the column. So there's two reasons this is not the reduced row echelon form.
All right, so basically we don't care about the column that doesn't have the pivot.
Correct.
Okay.
And the fact that the non-pivot column is all zeros is not relevant. That would just mean if this was the augmented matrix of this would be the augmented matrix of an inconsistent system because it's a pivot in the rightmost column. If I put a column of zeros at the end of it and say, then what that would mean if this is x1, x2, x3, x4, and x5 is that x3 is a free variable and it's not related to any of the other variables. That's all that would happen here.
Can I also ask like a clarification question on part C of this exact problem?
Yes.
Yeah, so basically I looked at the answer because I thought it was just in row or like reduced row echelon form for part C, but basically it's neither because there's a row of zeros right in the middle of the matrix. But let's say we were to switch like the last row and the third row, would that therefore be in reduced row echelon form?
That is correct. In part C, to get into echelon form or reduced row echelon form, all the rows of zeros have to be at the bottom. And so you'd have to switch the third and fourth rows in part C to get reduced row echelon form. So that's the other requirement for an echelon form. All the zero rows have to be at the bottom. Note that zero row does not mean that we have anything about the solution set. We're just talking about the form of the augmented matrix or the matrix in general. (1.2) question 10 is about writing a general solution based on an augmented matrix. So that's a different kind of problem. Let's do that one. So we have the augmented matrix of a linear system. So 1, -2, -2, 4, -1, 5, and 4, 6. So we're not just looking at any matrix. This is the augmented matrix of a linear system. So that's what we're given. We want to write the general solution. So for that, we need to find the reduced row echelon form. Our best way to find the reduced row echelon form is to just think about it and just use our incredible abilities to compute things in our mind without having to use technology of any kind. So let me just think about this and not just use technology and rely on that to perform my row operations. Let me double check in my mind if everything is correct. 1, -2, -1, 4, -2, 4, 5, -5, 6, 1, -1, 1, -2, -1, 4, -2, 4, -5, 6. Yeah. So not using any technology of any kind, let me write the reduced row echelon form of this matrix. So we get 1, 0, -2, 0, 0, 1, 2, -2. No, oh, dang it. My camera was on screen my calculator was on screen the whole time. So, quick side note on this problem. Actually, let me write the general solution. So, this is an augmented matrix. So the last column, the rightmost column of this augmented matrix is not a pivot column. So the system is consistent. We need to write the general solution. Each of the previous columns correspond to the variables, x1, x2, and x3. x1 is a pivot. The first column corresponding to x1 is pivot, so x1 is basic, and x3 is basic. And x2 is corresponds to a non-pivot column, so x2 is free. So I'll say that x1 If I solve this, this equation says x1 minus 2x2 is equal to 2. If I solve for the basic variable in terms of the free variable, x1 is going to be 2 plus 2x2. That's what this first row says. x1 minus 2x2 equals 0. So we solve for x1. x2 is a free variable. So I'm going to write x2 is free. And x3, this last row, corresponds to the equation x3 equals -2. So x3 is just -2. So here is the general solution. It was not part of this question to write the parametric vector form, but if we wanted to, the constant vector x1 is 2, x2 is 0 in the constant, and x3 is -2. So 2, 0, -2. Plus x2 times x1 is 2 x2s, x2 is just 1 x2, and x3 has nothing to do with x2. So there's the parametric vector form. Here we have the general solution. And here we have the parametric vector form.
So for the general solution, we don't have to always get the number.
No, we have, because remember, when we have infinite solutions, our job is not to just observe that there are infinitely many solutions. We have to specifically write down the form of those solutions. And the first way we learn to do that is the general solution. And that's what we're working on in this problem.
Gotcha.
Free variable in the middle, like in the quiz. Because the free variables aren't always the last ones. Some quick observations for DVD bonus material before I go on to one of the last problems, which has the weird H's and K's in it. We only needed to perform row operations to figure out this 2 and the -2 at the end. Notice that the first column is a 1, 2, -2, and the second column is -2, 4. The second column is just -2 times the first column. And look what happened in the reduced or echelon form. This 1, 0, -2, 0 tells us the second row, sorry, the second column is just -2 times the first column. Notice that -1, 5 is not a combination of 1, -2 and -2, 4. That's why the next pivot showed up there. I can't make a -1, 5 out of a 1, -2 and -2, 4. What I'm doing when I'm making these observations is I'm thinking about an augmented matrix of just these two vectors. What if it was just those two vectors? If we look at the reduced or echelon form of that 2 by 2 matrix, it's the augmented matrix of a consistent system because the rightmost column is not a pivot column. And it's just -2 times the first one. If I look at this as an augmented matrix, -5 is not a combination of 1, -2 and -2, 4 because it is an augmented matrix as a pivot in the rightmost column. Also notice that with 1, -2 and -2, 4, all we're ever going to get is multiples of 1, -2. So that's just some DVD bonus material. I didn't write that down. I just said it out loud, so it's not going to show up in the notes, but it will be there in the video. Let's check out one of these problems. I know we're a little bit over time right now, but I want to do at least one of these problems that has H's and K's in it and how we need to deal with that. I'm just going to use the one that's right here in section 1.2. You can use similar technique in section 1.1, but in 1.2, problem 20, we have a system, and I'm going to write down the augmented matrix for this system. 1, 2, -3H, and 1K. I'm going to write down the augmented matrix for this linear system because the augmented matrix is the way. And when we're looking at an augmented matrix, we want to find the reduced echelon form if we can get it, but at the very least an echelon form that we can get used to work backwards. So I'm going to pivot in this first row. I'm going to use that 1 to get a 0 below. So I'm going to do -2 times the first row plus the second row, and that's going to be my new row 2. The first row I'm not changing, but let's see. I'm going to do -2, +6, and -2. -2 and 2 is 0. 6 and h is h plus 6. -2 and k is k minus 2. Here's my new row 2. The next thing we would want to do if we want to get reduced echelon form is try to get a pivot in the second row, second column. And now we have to start making decisions. Now we're breaking things into cases. Can I do a pivot with this h plus 6? I'd want to put a 1 there, so I'd have to divide by h plus 6. So should I just divide by h plus 6? You could probably tell by the tone of my voice that the answer is no. We can't just divide by h plus 6 without knowing more about h. What's the problem with just dividing by h plus 6? Where could that go wrong for us?
Could be 0.
If h plus 6 is equal to 0, then I do not get to pivot right here. So this is how we start making our decisions. If h is equal to -6, there's no pivot here. So now we can say if h equals -6, then no more pivots. In the second row, I should say the second row, second column is not a pivot column. Everybody see that? If h is -6, then I don't get to pivot right there. If h is not -6, then we do a pivot right there. Now remember, this is the augmented matrix of a linear system. So I'm going to also say if h equals 6, then we get a pivot. Second row, second column. Now I need to think about the implications of these two cases. If h equals 6, then we'll have a pivot in the second row, second column, which means that we will definitely not have a pivot in the rightmost column of the augmented matrix. No matter what k minus 2 works out to be, if there's a pivot with, if h plus 6 is not 0, we will not have a pivot in the rightmost column. Therefore, this will be the augmented matrix of a consistent system. If h equals -6, then we do not pivot in the second row, second column. Then we have to look at the values of k, and maybe there's a pivot here and maybe there's not.
Sorry, how did you get h equals 6?
I'm just trying to say what will make, -6. If h equals -6 is not, that's what happened. I use the negative as this, I see what mistake I made in my brain now. Yeah, my mind played a trick on me. If h is not -6, if h is 7, then 7 plus 6 is 13, and we can do a pivot in the second row, second column. That means there's not going to be a pivot in the rightmost column of this augmented matrix. Therefore, this will be the augmented matrix of a consistent linear system. If h equals -6, then that'll make this second row, second column 0, and we won't get to pivot there. That means we have to look at the values of k. If we have a h is -6 and k is equal to 2, then we have a row of zeros. But more importantly, that doesn't tell us anything. We don't have a pivot in the rightmost column of the augmented matrix, therefore we have a consistent system. But if h is -6 and k is not 2, then we'll have a pivot in the rightmost column of the augmented matrix, and therefore the corresponding system will be inconsistent. If that seems like a lot to remember, well, that's only because it's a lot to remember. This is the kind of thinking that we need to apply to all the problems that were suggestions. So in section 1.1, number 20 and 26 have the same issue. You need to perform your row operations by hand and then look at where your pivots are going to be. Any questions?
Sorry, just for the clarification, just for myself, I just want to see that if I'm right or not. So if h equals to -6, we have two options because we get the 0 for that part. So the next column for the k, it could be 0 or a number. So if it could be 0, which means that k equals to 2, so then we have many solutions. So it's so it is consistent. But
Right.
if k it's not equals to 2, so we have a number. So then we have 0 equals to a number, which is not true. So the system is inconsistent.
Correct.
Okay, thank you.
Yep, those are the three things that could happen. 0 solutions, exactly 1 solution, or infinitely many solutions. Very good analysis. I like it. How's everybody okay? You can use that discussion to go back to 1.1 and check out those two problems, 20 and 26, because they use the same kind of thing. Notice that I wasn't able to get to reduced or echelon form because I don't know what's going on with this h plus 6. That might be 0, can't divide by h plus 6. Because we don't want to divide by 0. The math cops will come and get us. I'm sure you've all saw that show. Math cops, what you're going to do, what you're going to do when you divide by 2. So it's very bad. You don't want the math cops coming to your door. They like carry calculators. See this? They just convert this into a holster. Then they just, like the math cop detectives wear it in a shoulder holster right here. And so if you start messing around and start dividing by 0, it's like, oh, excuse me, sir, I'm going to have to ask you to not divide by 0. I've asked you to not divide by 0. See, but then they always have to, before you, as you're, you should run away when they're like, oh, hang on a second. You know, does it go on the bottom? Oh, they got away. Anyway. But you got to watch out. This is actually Texas Instruments. I don't know if you can see that. Texas Instruments. I think in Texas, if you buy a Texas Instruments calculator, one of the options is that you can actually load it. I think there's a 45 TI-80. There's a TI-80 45, and then you can just like one of the apps is like all fire because it's, I mean, it's Texas. So I'm just kidding. Go ahead and make nasty comments about me in the comments, Texas Instruments, because I disabled the comments. Ha 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 ha. I'm just kidding. That would be crazy. Put bullets in your calculator. I can't even put batteries in this one. So is this the rechargeable one? Anyway. I'm glad that got recorded. All right. Sorry for going overtime today. I also don't edit my videos, so go ahead and make fun of me, Texas, for being from California and not being able to load my calculator with 45 caliber rounds. I'm just kidding. This is like the thin calculator. It only comes in 22 long rifle. So what are we talking about? Oh, yes, putting bullets on our calculators. All right, that's going to do it for today. Get started on homework 1.5 and 1.7, which is about solution sets to vector, matrix, and linear systems, and 1.7, which is about linear independence. Think about how we characterize linearly dependent sets and think about how we can read the pivots. That's what we want to look for. All right, that's it for today. I will see y'all on Wednesday when we'll talk about the important concept of span. You're going to start on the homework without me talking about that at all, so it'll be really funny. That's it for today. I will see y'all on Wednesday, and thanks for